Welcome back. In our previous lesson, we have looked at how we can determine the domain of a function. So we've considered various functions and we have looked at how we can find the domain of the function. My name is Nanaya Wedu and you can call me Senana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. In this lesson, we want to continue and look at another example on how we can find the domain of a function. So let's consider this example. So we are to find the domain of the function, and the function given is f of n is equal to n plus 5 all over n squared plus n minus 12. So by now, I believe you know the type of function that has been stated here, right? So this function we know is a rational function, any function that is of the form f of a all over g of b, right? It's a rational function. So let's look at how we can find the domain of this function. So basically, the function that have been given to us, when we look at it very carefully, is a function f of n, right? So let me write it, f of n, which is equal to n plus 5 all over n squared plus n minus 12, right? So basically, to be able to solve this, we must approach it by looking at the denominator, because when the denominator becomes 0, the function becomes undefined. So we'll take the denominator and equate to 0 and find those numbers or those values that can make the function undefined. So we have n squared plus n minus 12 is equal to 0. And with this, we can work the bottom-up approach to finding a quadratic equation, because we realize that this is a quadratic equation where we can solve and have two values. So you can take your calculator. Let's go through that. If you have not probably gone through that video of finding the numbers or the functions when you have a quadratic function, you go to mode and then you go to 5 that represent the equations, and then you pick the equation that is of the form as squared plus bs plus c, right? So the coefficient of the first one, which is the n squared, is 1. So you punch 1 and go to equal to. The coefficient of the constant or the n term is also 1. So n1 is equal to, and then the constant, right, is negative 12. So you punch negative 12 and it's equal to, and then you have the values of n, right? So you leave 3 lines and then write the values of n. So n is equal to negative 4, right? If you do it well, you get n to be equal to negative 4, and n is equal to 3. So you are going to work from the bottom to the top. So we'll move the negative 4 across the equal sign. We are going to have n plus 4, which is a factor, right? Then we'll move the 3 across the equal to sign. We are going to have n minus 3, which is also a factor. Then we equate it to 0, right? So we pick the n value and then we expand it over the n minus 3. So we have n minus 3, and then we pick the positive 4 value, and then we expand it over n minus 3, which is n minus 3, which is equal to 0. So expanding this, we are going to have n squared, so we can have our two factors, right? And then negative 3 multiplying the n will be minus 3n. So one of the factors is minus 3n, and then 4 multiplying n will be plus 4n, right? And then we have 4 multiplying 3, which will be negative 12, is equal to 0. So we can put the first 2 into brackets and then the second 2 into brackets. So the factors were negative 3 and 4. When we multiply negative 3 times 4, it should give us a constant c, which is negative 12. And when we add negative 3 plus 4, it should give us, right, the n, which is 1, right? The coefficient of the n, which is 1. So therefore, we can say that the domain of this function, right, in true set form will be x such that x is a member of all real numbers except for when x is equal to, right? So where x is not equal to, or you can write it as except for where x is equal to, right? So where it's not equal to negative 4, right? Or n is not equal to 3, right? So the value given to us was n, not s. So you see, when you use x all the time, they give you n and you might probably still be writing x, right? So be very, very particular about that. So that should be n such that n is a member of all real numbers, right? Except for where n is not equal to -4, or when n is not equal to 3. So the values here, right? So where n is not equal to, let me use a red for emphasis, -4, or where n is not equal to 3. Right, so this will represent the domain of the function, because when we put -4 into the function, you realize that the denominator part of the function becomes 0 and the function becomes undefined. And when we put 3 into the function, you realize that the denominator becomes 0 and therefore the function becomes undefined. So when you are given a quadratic equation at the denominator of a rational function, you would equate it to 0, find the values of that quadratic equation, and use those values to be the exceptions within the real number system. So in this question, we have looked at how we can find the domain of a function. We have considered we can find the domain of a function where we have a rational function where it's in the form of f of a and then g of a, right? And then we've seen that for that, the denominator was a quadratic function, so we equated it to 0 and found two values. See you in the next lesson.